Hello everyone, welcome. So the component tester or transistor tester has arrived. I remember ordering it some time ago. That's how it was packaged. More foam. And there it is. What are these for? This actually looks nice. Oops. So this is supposed to be the power jack. What about this? Okay, I think I should get a manual for this, but for now I'm just going to take a look. It says transistor tester up here, if that is visible on the camera. There it is. Let's power it on. So I powered it on and this is not visible on the camera. Is this? It's actually saying something. Battery 8.8 volt. Okay, then something in Russian, a question mark. If I move it, okay, how do I change the language? What's this? Yeah, I think I should really get the manual. Okay, so I checked and I could not find a manual for this. I went to the AliExpress listing that tells how it's manufactured and etc. and certain other details, but what I was looking for is a guide how I could change the language. Now they are using an Atmega 328p right underneath there. You can see some of the pins. Just an Atmega 328p. So this is basically an Arduino with a lot of other parts such as some transistors, some resistors, diodes, etc. And this probably used to be some sort of a project that later came into being as a transistor tester. Now I have seen the EEV blog video about this that says that the $7 component tester, and Dave Jones reviewed it, and that was nice. This is one of those versions. That one uses an STM32 based core, and this uses a Arduino and a 16 megahertz crystal. Now what the problem was that the language is in Russian. How the Russians say it, Mother Russia. I'm not good at it. Anyway, let's turn it on without any component here. First it will tell you the battery voltage, and this means testing. And then if you see this, oh wait, you can't see that. What do I do? Can you see that? Now it turned off. damn it. Okay, you can see probably that the battery volt in this menu, this thing tells you that missing, or I used Google Lens to find out what these things mean, and this here says missing or damaged because there is nothing here. It's not finding anything. Turn it on again. You have to press this to turn it on, and there is a function inside to turn it off. Then you twist this a little and you get a menu. So I used Google Lens on all of this, and this first, oh man, I have to turn up the light. Okay, now I think it's visible. Okay, I'm using it, as you can see. The first on top, this heading says that select. It translates to select, so it wants me to select from any of these menu. There are some functions. The second, where the arrow is right now, this translates to as switch off or turn off. Next we have, oh, it turned off again. Next we have this transistor test. This TECT means test. And then we have frequency generator, frequency monitor, as far as I remember, and this is the F generator or frequency generator. Next we have a 10-bit pulse width modulated signal from one of the outputs. There are 3 screw terminals. Okay, it's centered. There are 3 screw terminals. One is for the voltage, one is for the frequency generator, and the other is probably for this, and the other is probably for this 10-bit pulse width modulated signal out. And then you have the C plus ESR at the rate of TP 1:3. This probably means the ESR tester on the pins 1 to 3, 1 and 3. If I could show you, there are markings here saying 1, 2 and 3. So these 3 are 3, these 3 are 1, and in the middle you have 2, and same applies down here. Okay. And next we have this inductance measurement. I had to turn on the light because I myself was unable to show you this these screw terminals. This one says V. This one used to say pulse width modulation, but they used a red marker and sort of erased it, so I haven't tested these 2 yet. This one also says shows a square wave. This one also shows a square wave, so there is certainly some confusion. And so let's go on with the rest of it. Then you have a polymer or non-polarized capacitor tester, and this down here, C in bracket microfarad and cope something. This actually means the capacitor factor correction or something. If you have tested a capacitor to be 100 microfarad by, let's say, 10 fluke multimeters, and then you test it with this one and you see that it is only 90, so you would actually go ahead and increase by 10% or something, maybe 11 something percent, so you actually can adjust it for the mistakes it does. Then you have this function, which means, let me think, this means self-testing or something. But when I press this, a message with an exclamation mark comes out, which says shut up. It just says shut up according to Google Translate. Then you have this so next you have this BO something function, which is actually the voltmeter. And next you have for front color and back color. Now these 2 are to adjust the color of the screen. The front, why do they call it front? I guess there are 2 layers here, the background layer and the foreground layer, but they could have called it font because it basically changes the color of the fonts. The back color, you can just set these 2 to any combination of RGB and you will get the desired color. Then there is the DS18B20, which I have checked is a temperature sensor in the package of a transistor. Hope you can see that. And you could plug it in here and then measure the temperature since you have an Arduino. It's basically an Arduino, everything else. Then you have the DHT11 temperature sensor. This is basically the DHT11. Next you have this IR decoder and IR encoder. This is why they included those IR LEDs in the 3-terminal IR receiver. And the next option means information, and if you press this you will get some information about the parameters and about certain transistors, well, maybe all kind of transistors including BJTs, IGBTs, MOSFETs, JFETs, whatever. And then we are back to that shutdown function. So how many functions does it have excluding the settings? This is not a function, so that's first with the transistor. 1 2 3 4 5 6 7 8 9 10 11 12. Yes, 12 functions. What you could do with this is test transistors of almost any kind, use it as a signal a signal decoder and a signal generator and function generator, and then pulse width modulated signal if you want to run something like an ESC, I guess. And then you have ESR tester, which is very much necessary for me because I did not have any ESR tester. I need this. Then the inductance tester. Oh, I am finally so happy to get something that can measure inductance. Then there is this capacitance tester. Now I have compared it to my multimeter and it seems that this one is somewhat more accurate. I don't know why. And then you get voltmeter, these two specific sensors, and the IR encoder decoder function. So that's about it. Let's show some of the demo. Now I left my box of semiconductors at my campus, at my dorm room, and I don't have a single transistor to show you any of this, the transistor test. And then we have this function generator. No, this is the function. It shows you the function if you just input probably in one of these two, and it will give you in hertz what the signal what the signal is. Let's go back. And then this function generator, you could actually beef it up. First you think that it only can generate 9 hertz, but no, if you press it you can somehow, I don't know how they did it, but they sort of made it. You can even get a lot more digits here and make it up to few kilohertz maybe. Let's see, 10 kilohertz, 20, 30, 40, 50, 60, 70, 90 kilohertz. Let's add another point. Now it says R something kilohertz. Now I don't know what any of this really interprets to. I'll have to test it with an oscilloscope, what's really happening here. Now let's go back. Wait, you cannot go back from this menu, you have to pull the plug. They could have included one more button to go back or something. Yeah, nothing found. Rotate it a little. Where was I? So the function monitor and the function generator, and then you have the 10-bit pulse width modulated signal, that's probably here, and this ESR tester. Now I do have my box of passive components. So here I have some electrolytic capacitors, 2 new and 2 old. Let's try each of them on this ESR. I just selected that. Come on. Yeah, it entered the menu. Now we just plug it in from perhaps 1 to 3 and then lock it, and it will tell you the capacitance is 945, and this is a 16 volt 1000 microfarad capacitor. And it also tells you the ESR right now is 0.01 or something ohm, which is, I guess, good because it is a new one. Let's get it out. Another one that says 220 25 volt. Let's test the ESR of this one. This says exactly 225. How is this so accurate? Actually 220 to 25. This sounds too accurate to be true. Okay. Then I have this one. It's a bit used from some old CFL or something. You can see the voltage rating 400 volts, 5.6 microfarad. Let's plug this in, lock it, and whoa, look at that ESR, 4.1 ohm. The capacitance is okay, but that ESR, you can see that ESR is too high, I guess. Here's another one. This also says 400 volts and 3.3 micro. Let's plug this in, and this is very fast. You don't even have to lock it. You can just hold it here and it will tell you, like on these two terminals you can just hold it, these two terminals, and it will tell you 7.1 ohm. This is out of question. Why am I keeping this? I should use this for a show, like give it some extra voltage and blow it up or something. Okay, next go to the menu, and here is the inductance tester. Let's enter that. Do I have some inductors? Here is one of unknown value. Let's test that from 1 to 3. Oh, come on, get in. Okay, it says 0.1 ohm and L for inductance, which is 0.04 millihenry. I don't have anything to test this against, like how can I verify if this is correct? But I do have one inductor that is probably marked. I have several that are marked. Let's try this. And see, I'm having to sort through some of these. We can try this one. And then this one. Oh, look at this. And this one is marked. It says 150 microhenry. Okay, so we can use this as a sort of base, probably, to check all the others. Now let's say this has a 5% tolerance, so it could be 157 or 143, I guess. Okay, why is it jumping? Because if you touch it anywhere here, then it takes your static or something, it jams the signal. Let's test this on the inductance tester. Things need to be bent just a little. Okay, it went in. Lock it in place. Ah, look at that. 0.14 millihenry, so that is 140 microhenry. Okay, 150. Look, it's jumping from 4 to 5, which means there is just a single digit that's changing, so it's actually fairly accurate. Okay, let's test the other ones. This one has no marking. Let's test this one. Just press it here. Come on. .45 millihenry, so that's 450 microhenry. It doesn't look that big. Then there is this one. It's a choke, I guess, or some sort of a current sensing. Let's test this one. It says 0.01 millihenry. Not sure. And then we have this one with, say, it says 985p. What does that mean? Let's put it in here and test it. This one says 6.25 millihenry. I can probably test transformers to see how big of an inductance it can hold, but that is probably stated in the listing. Now let's go back, and there we have this polymer capacitor tester. Let's enter this menu and use some of these film capacitors. What is this? Propylene or something? Who knows? Okay, so it's 514 or 15.6 nanofarads. The ESR is 0.02, which seems okay. The V loss is 0.3. And what does it say? 684 K type. I mean, the K is probably for the tolerance, and 684, close. Then we can plug in this one. This one says 474, also K. Okay, 395.9 nanofarads and almost 0 ESR. So these are okay. Okay, you probably get it now. The next function, as I said, you can just enter it and change that value to adjust for the capacitor, and you cannot go back from this menu by just pressing it or doing anything. You have to unplug it. Okay, just gonna call. Let's unplug it and replug it and turn it on. Okay, where was I? This PEXNM whatever, this is supposed to do self-testing, but when I press this and I use Google Lens on this, it says shut up. I don't know if that's a joke or it's asking you to turn it off or anything, but if you even press it or like rotate it, because there is no other control, nothing happens. You have to unplug it again and turn it on again. Again, rotate and go to the menu for this voltage test. So here I have a battery connected with alligator clips on these two, and by keeping the polarity in place, I'll just check. It says 4 volts, which means it's almost charged. I was recharging them. Now let's go to the menu again. Now this specific sensor I do not own yet, but I plan on getting it someday. And then this DHT11 I have it back at my dorm. The IR encoder decoder, they are included inside, and they probably follow some sort of a protocol to encode or decode. Like for example, if I enter decoder, it wants you to plug in that, and then you'll get to do rest of the things. Okay, if I put it inside a package, I would like to add a switch, because you have to turn it off every now and then. It's amazing how they could just use an Arduino and make an entire equipment out of that. Okay, you saw the voltage, the front color and back color, not that important. And then we have this information. Let's press it, and we can rotate this to find that there are many information, like the version, if you want to look at them, and then we are back to menu, and then we can just press this while keeping it on this option, turn it off. Okay, there is a simpler method of testing it. Let's say you don't know or you don't want to go through all the trouble of going to the menu and selecting any of this. You can, I mean, it's originally designed as first you insert the component and then turn it on, and it will automatically detect whatever this is. Since I don't have any semiconductors here, I'm just going to test some random things. Start with this LED between 1 and 3, and then lock it, and then turn it on. And it tells me that from 1 to 3 there is a diode. This is an LED, a light emitting diode, and the voltage drop is 2.87 volt. There is a capacitance which is 230 picofarads, and IR, is that the current consumption? 6 nanoamps. Oh, what is that? I don't know. Let's try something else. This LED, orange one. This also shows some parameters like the voltage drop, capacitance, and IR. Let's try this IR reflective sensor. Let's plug this in the right way, like this, and reboot. Nothing found. Why? Okay, this is the receiver. It should get something. Then again, the transmitter. Okay, this one reads 1.17 volt drop, 5 picofarad, and the third parameter, who knows, maybe very little, so they decided not to include it anyway. This is an inductor. Put this in. Oh, come on. Put this in and lock, and then reboot. So it shows a it automatically goes to that inductance test and shows you that there is a 1.5 with a 0.09 millihenry inductance. Then let's try this known value. I know the value of this because when I bought this, the listing said 100 microhenry perhaps. test this. Gain reboot. Yes, 100 microhenry or 0.10 millihenry. Okay, then let's try this capacitor. Okay, turned off. Now let's press it in and turn it on. It goes to that capacitor automatically and says 102.3 nanofarad, 104, so 10 followed by 4 zeros. It's accurate. The ESR, why does it seem a little high? I don't know. I probably need to look at the chart. Okay, let's try one of these dual resistors or potentiometer. It's basically two resistors. It will show up as two resistors. Notifications. Okay, there it is. It's almost halfway rotated. One is 2600 and from 1 to 2, and then from 2 to 3 it's 2500, so altogether 5k, 502. And then let's try just a few resistors. Let's try the big one. It says 120 ohm. Press it in, lock it in. It goes to the inductance, no, the resistance. First it tested like, what is this? It tries to identify what the hell is this, and it shows me 119.9. that's exactly 120 ohm. And then let's try some small resistors. Such as this one. Press and lock and reboot. Come on, reboot. Testing, testing, testing. 33.6 kilohertz, which is exactly as it says. 33, 3, 3, and then 3 zeros. Let's try a green LED just for no reason. Okay, that's bright. Voltage drop is 2.5, capacitance 15 picofarads, IR 2 nanoamps. What else can we try? This is a very high quality capacitor. I ripped this off from some computer motherboard made by Asus. Can I plug it in? The legs are probably not long enough. Let's try it anyway. Okay, it is. Yes, it's in place. Testing. Hmm. 727.4. It's supposed to be 820, 6.3 volt. And look at that ESR rating. It's nice. Really high quality. This is some shit quality. Oh, I'm not supposed to say profanity. Let's call it feces quality. You see that rating? Dangerous. You can't use this anywhere. Okay. What else can we try? Oh, I wish I had bought my box of semiconductors. I could test if this can identify voltage regulators or some sort of other parts except for transistors. I don't think it can recognize voltage regulators. Maybe it will recognize it as a diode or something, as Dave Jones showed. So I'll be uploading this video without any of those. If you really want to see, maybe when I get back to the dorm room, I'll do another video as a part 2. But I already think it's good enough for basic component identification. Let's say you're just confused about whether it's a PNP or an NPN, and looking at the datasheet could take finding the datasheet and then scrolling, etc. So you just plug it in here and test quickly which pins are what and what other parameters it may show. Okay, so I plan on taking the chip out, copying the contents if possible, then editing the code and changing those specific Russian words into English, and that's probably it. To sum up this whole video, I would say that this is a very cheap yet useful thing. Like for me it cost around 1000 Bangladeshi taka, and $1 is 80 or 84 Bangladeshi taka, so you can do the calculations. And it had actually 4 options for purchase. The first one was the lowest. They would just give you all the components and everything, and you'll have to hand solder it. Or you would get this prepared this equipment, or you can also add the box. Now the box I did not buy for saving 200 taka or so. I'll make a box out for it anyway. But it seems that except for the LCD, nothing else is actually in danger. Like everything is quite covered up. So let's see if I can put a plexiglass on this LCD. And with all that said, I hope it summarizes the video and this topic. See you in my future videos.